Go to create project template, choose microwave RF optical, then antennas. That you choose planar antenna, choose time domain, then check all the units, millimeter, gigahertz, Kelvin, then press next. Here you have to choose the frequency. Minimum and maximum frequency are entered here. So I prefer to go to everything RF, and there I'm going to determine my frequency, which is 2 gigahertz. So for that I have the width 46 and length 35 millimeters. So there's an inbuilt formula where you calculate the width and the length of the antenna, patch antenna. So enter frequency minimum in gigahertz. So I'm going to enter here 1 and 3 because I need frequency 2. I'm check marking E field, H field, far field, power flow, power loss, and I'm going to define it at 2 gigahertz, just 2 gigahertz alone, not at 1 and 3. Then press next, then check everything, antenna planar 1, and press finish button. So you will have the complete template here, the navigation tree, the schematic tab, the 3D tab, then parametric list. In the parametric list you are going to enter the length of the antenna. So I represent it as L, and the value is what you determined there, 35.8 millimeter. Then width of the patch is represented as capital W, which we have determined 46. Then you know the length of the ground plane, width of the ground plane, H, everything is written as such. So ground plane length and width are going to be twice the length and width, and H is equal to 1.6 millimeter. All those details are entered here. Next we are going to enter the T value, the thickness of the patch, which is 0.035 millimeter, and your substrate is going to be 1.6 and the patch is going to be 0.035. So you can use these tabs. Then go to the square, that brick button, click it once, then press escape. You get a tab like this. In that you enter, you're going to build the ground plane first. So an antenna patch has a ground plane, a substrate, and then a patch. So ground plane, so you are typing it as ground, then minus LG by 2, length of the ground plane. It from the middle, from the center point, is going to be x axis, no, so you have to type it as W, width WG minus WG by 2 plus WG by 2. Then Y, length is minus LG by 2 to LG by 2. So from the midpoint 0, it is going to be length and width. Then Z min is 0, Z max is T. You're going to choose a component now. So it's a patch, so you're going to load it from the material library, and you're going to choose FR4 material, not FR4, I'm sorry, copper annealed material. FR4 is substrate, this is ground. So for the ground you're going to choose copper annealed lossy material, you're going to choose from the library. And here we see all the materials. Here we'll go to copper. You can see copper pure and copper annealed. Yes, choose that and load it. Then preview it. You will see the outer lining of it when you preview it. Yes, orange lining. Then press OK. You will see a yellow material. Yellow, it is represented in yellow. Yes, this is the ground on the frame from 0 to T thickness. Thickness is 0.035 millimeter. Okay, upon it we have to build uh, the substrate, okay, which will be of the same size. So again go to the brick, then escape. Now substrate same length as that of the ground and the substrate are of the same length, so again minus x is with the wg by 2 to x max is wg by 2 minus wg by 2 to wg by 2, then come to y min minus lg by 2 to lg by 2, then your z min is going to be t to t plus h, because upon the t you are going to build 0 to t that means t to t plus h is 1.6, and it is a new component which is substrate, so type substrate and load the material from the library, and this substrate is a FR4 material, so we are going to FR4 lossy, load it. Yes, so again you can preview it. It is going to be a white material in representation here in the software, and you can click OK after looking for the preview. I straight away pressed OK, then you can see below you have 0.035 thickness copper, and above you have 1.6 millimeter thickness substrate. Upon this substrate you have to build a patch. Now, so using the tabs you can rotate and see, you can rotate, you can dynamically zoom it, you can pan it. Now again you can go to the brick tab and type patch x min. Now you know what L value, capital L and W, capital W value, minus L by 2 to, sorry, this is width, right, minus W by 2 to W by 2 x max. Then for Y min minus L by 2 to plus L by 2 length. And this is thickness is little tricky because you have to build upon the substrate exactly. So 0 plus T is ground, T plus H is substrate. Now T plus H to 2T plus H, that's T plus H plus T. Again it is going to be 0.035 millimeter thickness. Okay, so either you can put 2T plus H or T plus H plus T would be fine. So the component is patch, so that you can identify it. Why we are naming it? Because in the component tab you can name it as a, you can easily identify it, which is a patch, which is a ground, which is a substrate. So component, enter the same ground component you can enter, or you can go to new component and type patch. And here I am loading it from the copper anneal, the same material. I can change the name as new component, which is patch, use the same material. Okay, so PATCH, preview it. Yeah, you can see the lining, and then you can click OK to build the patch upon the substrate. So now you will see an yellow material over the white substrate. If you once you click OK, yes, now our patch is ready, but still you need to construct the feed line. Okay, feed line. Our feed line should be having an impedance of 50 ohm, so that when you excite the feed line, it will send the signal to the antenna and it will radiate. So you have to calculate it. So you can find out the width of the feed line. W subscript F we can represent it as. So to calculate that, what we can do, we can use the software, and here I have calculated it readily. 3.137 is the width. There is a port here in the macros. You can use that to calculate the width. 3.137 is the width, WF. Okay, so now again you go to the brick. You have to name it feed line, and your X is the width of the feed line. So minus WF by 2 to plus WF by 2. So we know the width. So width is very important. Okay, only that will determine what frequency we have planned earlier. Then length is from the end of the substrate till the patch. So extreme end of the substrate is minus Lg by 2, right? Minus Lg by 2, and your Y max is going to be minus L by 2. Okay, because the edge of the patch is minus L by 2. So minus Lg by 2 Y min till Y max, which is minus L by 2. Then only you will have the feed line extending from the edge of the substrate to the edge of the patch. So you can go to the port tab generally to calculate the width of the feed line. You have to give the dielectric constant value and 50 ohm. You have to trial and error method. You have to find out like that. And Y max minus L by 2. Yes. Zmin is same as what we did for the patch, because it's built upon the substrate. So T plus H, Zmin, Zmax is 2T plus H. So T plus H plus T. Material is same as the patch. So we need not mix that up. If you want to show it as a separate component, you can type it as feed line and give the same copper annealed lossy material. Other material will not fetch you the right value. You can preview it and see exactly where we planned. Now both the material are separated by a line. Actually it is not, so you have to go to component, choose those materials, go to feed line, select it, and then select the patch to, because you're going to add these two, connect these two materials. So now you selected feed line, it is highlighted. Then patch you are selecting, it is also highlighted. Remove the ground. You can use the control tab to select, then press boolean add. You can see the line disappearing, and it is one material now, and you have no feed line data on the left. Okay, we are almost done, and we are going to pick now. Pick, and we have to go to macros. Before that, calculate. No, here there is a solver. Yes, port. We have to give port, solver, port, calculate port extension coefficient. Yes. Okay, so you see here the width, H value, and K is calculated. So to do that, first you have to pick the feed line. So just tilt the antenna and zoom to the feed line. Pick face, click pick face, and click the face of the feed line. Zoom it, you will see the phase where you have to give excitation there. You have to, yes, zoom it, yes, this part you have to click it, double click it, yes, you will get some dotted, red dotted line on it. Now you have to go to the macros to build the port. Macros, calculate, no, here you have to go to solver, yes, solver, and calculate port extension coefficient. Yes, the width automatically it is generated 1.6, 4.3. Then calculate, k is this value, then you can construct port impedance from the picked face. Okay, so w, k into h, k into h, everything is calculated. Waveguide port will be like that. The green place is a substrate. See, it is built now. So now we can run the simulation. So you can see the values projected: h, l, l subscript g, ground length, t value, w. T is the thickness of the patch, w, width of the ground. Some cases t they give it as 0.035, some cases they give it as 0.05. Here I think I have modified as 0.05. Now you can choose the simulation tool and you can run. Other options I am just showing you: extruding the face, and very many shapes are there for different antennas. Rotate face, you can see the antenna. Then now you can go to the simulation tab, you can see the waveguide ports. Go to home, click start simulation. Setup solver is there, you can see the time domain solvers, frequency domain solvers. Straight away you can click start simulation and it will start simulating the whole process. It will take a little time depending upon the speed of your system. My system is a i5 processor. It performs well when it comes to this software. I don't feel any lagging or system getting hanged, all that. So I'll show you the first result, and with the simple modification I'll show you the better result which is generated. Now that our result is generated, you can see in output port signals and S parameter, you see the dip is at 1.8 to 2, between 1.8 to 2 gigahertz, above, a little above minus 10 dB. Actually our result has to be little above 10 dB. It should go above 20, 30, but 10 is fine. 10 is a very minimum, and you can see another dip at 3 gigahertz, so which is not our desired output. So I'm going to do a simple modification. Okay, so moving. So the modification that I'm going to do is, so let me assume like I divided by 2. So my desired value is 2 gigahertz, 2 to 3, 2.6, anything, but I need a good output, good above 20, 30 dB I need. So 3 by 2. Okay, I would like to change. So 35.8 into CT for L, and now it is 3 by 2, not 3 by 3. Now if I run, my results will be different. You can see the comparison, what I got earlier and what is after the modification. Earlier, after simulation, we got a value which is lesser, And now after updating the values, you can press F7 to update and you run the simulation. You can see it is calculating. Now that my results are generated, I'm going to show you the S parameter value. Yes, you see here it has extended till minus 45 dB, not till above minus 45 dB, the green one. Red one was ours, the previous result. Green is after modification. You can see from minus 10 it reached up to minus 45 at 2.61 or something. Yes, 2.6. So if we move the axis marker to the minimum, it is minus 47.37. Minus 47.37. Red is not the desired value, but you see the green minus 45 47.37, comparatively a good result. You can check on other values also here, and 2.61 is the frequency that we have designed our antenna for, and the outcome is quite good at 2.61 gigahertz. We can also explore other parameters on the left tabs: power, energy, 2D, surface current, E field, all that. You can see the electric field, 3D here. The frequency 2 gigahertz we have given, but we have received 2.61. We can see how the whole simulation works, and I'm animating it here. You can see the surface current movement in the simulation, the arrows. Okay, similar results are there all through the antenna design. So thank you everyone for learning along with me. Thank you so much for supporting. Have a great learning.